What if you woke up tomorrow and the world was almost the one you knew, but not quite? Your favorite mug is a different color. A familiar street has a new building. You're not in a different place, you're in a different reality. This isn't proven science, but the idea of parallel universes is a fascinating concept being explored by physicists at the very edge of our understanding. While no empirical evidence for alternate realities exists, these theories challenge how we see everything. You wake up in a world that's nearly identical, but small details feel wrong. These 10 facts are your only guide to making sense of the infinite realities that might have just collided with yours. Fact 1. The infinite library of universes. First, our universe might not be the only one. The multiverse theory suggests our entire cosmos, everything we can see and touch, is just one bubble in an endless cosmic foam. This idea isn't new. It dates back to ancient Greek philosophers who imagined infinite worlds. Today, it's a theoretical concept in modern physics proposing that countless universes exist, each with its own history and maybe even its own laws of nature. Think of our universe as one self-contained reality, doing its own thing. Some might be nearly identical to ours, while others could be completely unrecognizable. This collection of universes is what scientists call the multiverse. The idea that everything we know is just one of many possibilities playing out all at once is the foundation for everything that follows. Fact 2. The fork in the road. The many worlds interpretation. Have you ever wondered what would have happened if you'd taken that other job? According to one of the most head-spinning ideas in physics, in another reality, you did. This is the many worlds interpretation, first proposed by physicist Hugh Everett III in 1957. Here's the gist. At the quantum level, the universe is all about potential. A particle exists in a haze of probabilities until it's measured. The standard view says this haze collapses into one outcome. But many worlds says there is no collapse. Instead, every single possible outcome happens, each in its own separate, parallel universe. Think of time as a tree that's constantly branching. Every quantum event, from a particle decaying to a neuron firing as you make a choice, is a fork in the road. A universe branches off where you turned left, and another where you turned right. This means there's a version of you who made every choice you ever thought about. Infinite versions of your life are being lived right now in realities just as real as this one. Fact 3. Cosmic bubbles and the never-ending bang. Let's go back to the instant after the Big Bang. The leading theory, cosmological inflation, suggests that in the first fraction of a second, the universe expanded exponentially fast. But some physicists believe that inflation didn't just happen once, they think it never stopped. This is the theory of eternal inflation. It proposes that while inflation stopped in our pocket of space, the greater fabric of spacetime is still expanding. Within this expanse, other regions are constantly halting their expansion, each time creating a new self-contained bubble universe. Our universe would be just one bubble in an endless cosmic foam. What's really wild is that these other bubble universes might have completely different laws of physics. The strength of gravity or the speed of light could have different values, leading to bizarre universes we can't imagine. This theory offers a solution to the fine-tuning problem, why our universe seems perfectly set up for life. If there are infinite universes, it's just a matter of probability that some, like ours, would have the right conditions for us to be here wondering about it. Fact 4. Echoes in the static. The hunt for proof. If these other universes are out there, can we ever prove it? Not yet. Most models propose realities that are disconnected from ours, but that doesn't stop scientists from looking for clues. One of the best places to look is in the cosmic microwave background, CMB, the faint afterglow from the Big Bang. Scientists have mapped this radiation in incredible detail, but there are some anomalies. The most famous is the CMB cold spot, a huge patch of sky that's far colder than its surroundings. One leading explanation is a massive supervoid between us and the CMB, a region with far fewer galaxies, but this has led to a more exotic, though highly speculative, hypothesis. What if the cold spot is a bruise from our bubble universe colliding with another 1 billion years ago? While this is an intriguing idea, no statistically significant evidence for such a collision has been found. Many cosmologists think these anomalies are more likely just statistical flukes, but the CMB remains our best telescope for possibly spotting a ghost in the cosmic machine. Fact 5. Higher dimensions and shadow worlds. We think of the universe as having 3 dimensions of space and 1 of time. But what if there are more? String theory, a leading contender for a theory of everything, proposes just that. For its math to work, it needs extra spatial dimensions, maybe as many as 10, all curled up too small for us to see. An even crazier idea comes from an extension called M-theory. It introduces brains, which are like multidimensional membranes existing in a higher dimensional space called the bulk. In this brain world scenario, our entire universe could just be one of these brains, and we might not be the only one. Other brains, other universes, could be floating parallel to ours, maybe just millimeters away, but separated by an extra dimension. Most of our reality is stuck to our brain, which is why we can't see these other worlds. But string theory suggests that gravity might be able to leak between brains. This could explain why gravity is so much weaker than other forces and opens the possibility that we could one day detect another universe by its gravitational pull on our own. Fact 6. Levels of infinity. Not all multiverses are created equal. The word multiverse describes a bunch of different theories. To clean things up, MIT physicist Max Tegmark proposed a classification system with 4 different levels. Level 1 is the most straightforward. It's just a consequence of space being infinite. If space goes on forever, then eventually the arrangement of particles in our observable universe has to repeat. Far, far away, beyond what we can see, there are other regions of space identical to ours. Level 2 is the bubble universe multiverse we just talked about, which comes from eternal inflation. Here, different universes are separate bubbles where the fundamental constants of nature might be different. Level 3 is the many worlds interpretation of quantum mechanics. These parallel universes aren't far away in space. They exist right here, now, on different quantum branches, constantly splitting off from our reality. Finally, level 4 is the most abstract, the mathematical universe hypothesis. This is Tegmark's idea that any mathematically consistent structure corresponds to a real physical universe. Basically, if you can describe a universe with math, it exists somewhere. We're exploring ideas where science starts to blend with philosophy. What do you think? Have you ever had a moment of intense déjà vu, a glitch in the matrix, or a memory of something that feels like it never happened? While these aren't scientific proof, they're what make the idea of parallel worlds so compelling. If you have your own theory about the multiverse, or you've experienced one of these weird glitches yourself, tell us in the comments. And if your mind is being blown, don't forget to like this video and subscribe. Fact 7. The simulation hypothesis. Are we living in a cosmic computer? What if our reality isn't a base reality at all, but an incredibly advanced computer simulation? This is the simulation hypothesis, popularized by philosopher Nick Bostrom. His argument is that if any civilization gets advanced enough to run ancestor simulations, they'd likely run billions of them. If that's true, then the number of simulated realities would vastly outnumber the one real one, making it statistically likely we're in a simulation. For a long time, this was just a thought experiment, but recently some physicists have tried to find ways to test it. Physicist Melvin Vopson has proposed a speculative idea called the second law of infodynamics. While thermodynamics says disorder or entropy always increases, Vopson suggests that in information systems, entropy tends to decrease as data gets optimized. He speculates this could be a sign of a universe-wide data compression process, something needed to run a simulation of this scale. These ideas are highly speculative, but they are among the first attempts to find physical evidence. Fact 8. The Mandela Effect. Shared false memories. This brings us to a stranger phenomenon, the Mandela Effect. The name was coined by researcher Fiona Broom after she found many people shared her memory of Nelson Mandela dying in prison in the 1980s. Of course, he was released and later became president of South Africa, passing away in 2013. Since then, other examples have surfaced. Do you remember a 90s movie called Shazam, starring the comedian Sinbad as a genie? Many people swear they do, but it never existed. Was it the Berenstain Bears or the Berenstein Bears? And did the evil queen in Snow White say, "Mirror, mirror on the wall"? The actual line is, "Magic mirror on the wall." These are specific, incorrect memories shared by large groups of people. The scientific consensus points to psychological phenomena like confabulation, where our brains unconsciously fill in memory gaps. But a more radical fringe theory asks, what if these aren't false memories? What if they're leftovers from a parallel universe, where Sinbad did play a genie? It's an untestable idea, but a fascinatingly strange explanation for a very real phenomenon. Fact 9. Escaping the Great Filter. Every civilization must face what's known as the Great Filter, a hypothetical barrier so difficult to overcome that it stops most intelligent life from becoming interstellar. It could be nuclear war, climate change, an asteroid, anything. It's one possible answer to the Fermi paradox. If life is common, why is the universe so quiet? Maybe no one makes it past the filter. The multiverse, however, offers a different perspective. If there are infinite universes, there are infinite versions of humanity. In some, we fail. Those timelines end. but in other universes, we succeed. We solve climate change, deflect the asteroid, and avoid the war. In this view, the multiverse is the ultimate evolutionary engine, ensuring every possible survival strategy gets tried somewhere. This connects to the anthropic principle, which states that we find ourselves in a universe that can support us because we couldn't observe it otherwise. Our survival isn't a lucky break, but a statistical inevitability somewhere in the infinite sea of realities. Fact 10. The ultimate question. Who are you? This brings us to our final point. The idea of alternate realities forces us to ask the deepest questions about who we are. If there are infinite versions of you, each living out every possible choice, what does it mean to be you? The multiverse challenges the idea of a single self. There isn't just one you. There's a you who's a famous artist, a you who's struggling, a you who's happier or braver. This blurs the line between free will and determinism. If every choice you make just causes the universe to branch, with a version of you experiencing each outcome, was it really a choice? This doesn't have to diminish your choices. You could argue it gives them ultimate meaning. Every decision you make doesn't just shape your world, it creates new ones. You are the architect of countless realities. The question then is which you will choose to be in this moment, in this reality. From cosmic bubbles to infinite branching timelines, the idea of the multiverse stretches the limits of science and imagination. We've journeyed through hidden dimensions, hunted for echoes in the universe's oldest light, and questioned the very nature of reality, memory, and self. These ideas are more than just mind-bending theories. They're a new way of seeing the world. A world where the line between what is and what could have been gets blurry, and where you are just one of an infinite number of selves. The next time you get a strange sense of déjà vu, ask yourself, is it just your mind playing tricks? Or did your world and another almost touch?